Welcome to another video on digital electronics. In this video we will be seeing what is a programmable logic array. So in last video we had discussed what is prom, in which you had a fixed AND array and a programmable OR array. But in programmable logic array you have both programmable. Why both programmable? The reason is, if you have 3 inputs, I have 8 combinations. But since I increase this input to 4, I will have 16 combinations. If I increase to 5, I will have 32 combinations. Means this min term is increasing exponentially. And will I be using 16 and 32 min terms in all the functions? No. I'll use very few number of min terms. And hence, to avoid this creation of multiple min terms which I will not use, I will rather select only those min terms, or I'll generate only those min terms which I require. So in spite of making this fixed, let's make this programmable. That is what we are doing here. So programmable logic array, I have a programmable and a programmable OR. So as the input increases, the min terms increase exponentially in the previous case, which we want to avoid. So I have a programmable AND array. Again I have 3 inputs and I will generate the product term or the min term that is required in the function. I will not unnecessarily generate all of them. And this programmable OR remains exactly same like we did previously. So PLA, it goes through minimization, which means what? I will not have a min term like a canonical min term. I will not have, which has all the variables. The minimized form of the min term I will generate. Common terms can be generated only once. Means if say this function has one term which is common to this function, I will not generate twice. I will generate it once and I will use here also and I will use here also, right? So common terms can be generated only once. It takes into account the shared product term. Whatever product term I can share with multiple functions, I will share. So let us see an example on this. I have f1 as a function of 3 variables. So this is entirely 3 variables. f2 as another function, f3 as another function. The function is given in an SOP form. So I will use K-maps to solve this. I am not discussing this in detail because it is understood by now. I will use K-maps and eventually I will get a reduced equation. Now to this reduced equation, I will find out what are the product terms required for me. So this is my first product term, my second product term, third product term, fourth product term and fifth product term. So P0 to P4, I have 5 product terms which are generated to implement all the 3 functions. Okay, so now what I want to do is I want to add one more function which is also function of A, B, C, and these are the min terms. So I'll again reduce this and I get the reduced equation. Now if I check this, B bar C bar is already generated as a product. So I need not regenerate this. I will use the same P1 here. BC is already generated. I will not regenerate. I will use the same P4 here. These are the common product terms. So if I want to add an extra function, there is no harm in doing it. There is no difficulty in doing it. What is the size of this? What is the size of this PLA? The size is having 3 inputs because it is A, B and C. How many product terms I am having? I am having 5 product terms, P0 to P4. And how many outputs I am having? Output is nothing but the functions, 4 functions. So 3 we already generated here and one more function which we are generating here. So the chip will define certain size and depending on our requirement, we'll select that kind of a chip. So I hope the concept of this is clear. In the next video, we will see programmable array logic. Thank you for watching.